Hi everyone, and welcome back to Fundamentals of Engineering with Farhad, Mechanics of Materials. Today we review an interesting concept in mechanical properties of materials relating to a stress and a strain diagram. If you look at a stress and a strain diagram, for example, of a steel or such material, you can easily see there is a linear part and it just moved to point A, which we call it like sigma proportional. And the reason we call that proportional is up to point A, there is a linear relation between a stress and a strain. And there is a dive down to point B, which we call it sigma y, which is upper yield. And just as you move farther to strain in the strain diagram, you reach to sigma y, which is a lower yield, and then it just moves all the way to point D, which is sigma ultimate or ultimate stress, and from ultimate stress it just dives down again to sigma failure at point E, which is fracture stress. The first part of a stress and strain diagram up to sigma y or yield stress is the area under this point is called modulus of resilience, and most of it is like in a proportional limit. What I mean by that is like if you consider here like sigma proportional, there is a small portion of modulus of resilience which locates in a nonlinear relation. So up to sigma proportional limit, there is a linear part and there is a small portion which is not linear but is still in modulus of resilience. So that's why we call it most of modulus of resilience is in proportional limit. And the slope and modulus of resilience, it just means the capacity of a material to resist under elastic deformation. The definitely you're familiar with the slope of this part, rise over run of this area is called modulus of elasticity, and we show it by capital E, or Mann's modulus of a material. And then if you draw a vertical line at the sigma fracture and consider the entire area of a stress and strain for example, a material like aluminum, steel, whatever you have, it is just called the modulus of toughness of a material. It just shows how tough a material is. Definitely this portion include the modulus of resilience as well, because the very first part of diagram, if you remember, this was the modulus of resilience up to sigma y, area under a stress and strain diagram up to sigma y called modulus of resilience, and up to sigma sub f fracture stress is called modulus of toughness. So the toughness is includes the modulus of resilience as well. Now let's for example, my bad, talk about, for example, if you look at a railroad coupler and they want you to withstand an impact load due to the conflict of these two parts of the wagons which are connected with these two railroad coupler. An impact load depends upon the toughness of a material. We need a tough material to handle that, like a excessive load due to handling those two or connecting those two wagons with each other. So again, to couple the two wagons of a train, we need a railroad coupler, which mainly comes from made from a ductile steel with large modulus of toughness. So it should be a very tough material to be able to handle those impact of those heavy loads. Thank you. We'll uh, talk in more detail about uh, ductility, toughness, and modulus of resilience in next video. Thank you.